Hello, I'm Arto Santala from Solita, and this is Surviving Database Transactions. So I got inspiration for this talk because I'm doing technical interview rounds for people who are applying to work with us. We have about 3,000 candidates a year that want to work with us, and then there's a few rounds of finding the good matches. So we are looking for good cultural and matches with good skills to supplement and refresh what we have. And technical round, we want to know if they have good technical skills. And if people are applying for lead position or they say that they have full stack capabilities, then we will be asking some database related questions. And I've seen that people are not always very aware of that area. So my thinking was that why not spoil a little bit on our interview questions. I try to create a presentation here, and if you have time to watch it, you will get a few answers for the questions that you will be posed, hopefully good ones, and you will be also educated and hopefully take a little bit of pain away from areas where you might otherwise have it. This is pretty basic stuff, so if you are already hardcore full stack supercoder, there is probably nothing new for you, but come along. There might be still worth checking it out. So every one of us now and then might have a really bad day, so it works on my machine. All the tests run just fine. But then we deploy it to production, people start using it, and then they break it. It starts failing in spectacular ways. And then when I try to repeat the problem again on my machine, I don't see it. There's data corruption, missing rows. What's going on? Why is data not consistent? I have a very simple example for you. So we have orders and we have products. This is actually order line. So idea is that product is our inventory. This is a table in database. And let's say ID1 is a carrot. So we have one carrot. Somebody is trying to buy it. So what is going to then happen is that we are going to insert a new line in our order. So here is carrot, one carrot, and then we update the inventory storage, so 0 carrots anymore. And here it's consistent. So before the transaction we have 1 carrot, and after transaction we still have 1 carrot, but the carrot has moved from one table to another. That's how the mind is thinking if this is a business logic operation. Let's say this is, and let's say that this is an attempt to buy something. So this is a part, there would be also more lines probably where you would update and add more things like order header and stuff like that. If you have not heard about ACID yet, now it's time to hear about it. So this is something that I often ask in interview, and not everybody knows it already. If you are not working with databases and you're not full stack or lead guy, you don't need to know this. But I would still say it might be useful to know this anyway. So listen up. Atomicity. When we have a transaction, we want all or nothing. So we want atomic unit. We want that all operations in our kind of business logic scope, function or method, we want them all to succeed, which is a good thing. But if one of them fails, we don't want to have like intermediate state in the database, some mess behind us. So we want to revert everything. We want to go back to the origin point, and there's many ways you can do this. Transaction logs, you can have kind of isolated instances of documents that you are working with. So you have many ways of dealing with this in database. That's not essential, but the concept is important. So atomic, all or nothing. Consistent. Before or after the transaction, we would assume that the whole state remains, well, not the same, but consistent. So it means that, as in previous example, if we had a carrot, we don't want carrots just to disappear or appear from nothing. We would like to have there be consistency. So if somebody bought the carrot, it goes away from inventory. Otherwise, it can be bought multiple times. The same carrot can be sold like million times, which is excellent business, but it's not going to last for very long. So it's excellent business for one day until you need to deliver those million carrots and you only have one. So I would not highly recommend it. Isolation. When you're doing multi-threading, which everybody pretty much is doing nowadays, if you do web application, you are multi-threading. If you have more than one user using it, or even one user doing multiple things at the same time, like in different browser windows. So isolation means that what can you assume about the data that's being changed, for example. So when we are doing an atomic unit, are you able to see the data that's being updated when it's not ready, for example? And there's also some other levels. Let's dive deeper into them soon. And then finally there's durability, and programmers typically don't do much about this. This is more to do with the database. So all this should be durable, and it should last. If there's power failure, it should be able to recover after the power comes back. And then if we have kind of some unexpected problems, errors, network issues, again, it should be able to be durable. It should be able to recover and carry on once things are normalized. So this is more about how databases deal with this. And word of warning, they deal with isolation and durability very differently. So different products have different rules on how these are implemented. Okay, here is an example. On the left side we have atomic unit. So I'm using here these brackets to signify that I want these to be run together. So I put a new line in orders and I update the quantity. And I put the right side here because we are doing same thing here, but here you can see that when two users are hitting the same spots together and doing the same thing, now we start to be interested on what happens with the data. Are we able to see the data when it's being changed? Are we able to, for example, when somebody added here an order, are we able to see the same order, and will this fail immediately, or will it succeed, or what will happen? And then we have another row here. If I just updated the inventory to 0, is this other thread going to update it to -1, or what's it going to see? So am I able to see the data in transaction? So that depends. We have some isolation problems that are potential. So we have lost updates, meaning that we have one transaction updating data, another one read something, and then it's going to change it. So what if they both read the same state? Let's say they both read the quantity and it was 1, and then they both set it to 0. So now we lost one update. Two threads went past, but we only decreased one step. So that would be lost update. Non-repeatable read means that you read one line of data and then you read it again and then it's changed. Then we have dirty read. A dirty read means that you will be able to see something that's in the middle of being changed, so it's not finalized yet. In this example, it might be, for example, that you just put a new order in, and here at this point somebody is checking the database, and they are now finding that somebody is making a fraud because we have a carrot here and carrot here. So that's a problem. Or they might see that we have an order and they act on the order, and then somebody rolls back the original transaction and order goes away. And then again, somebody is wondering what just happened. So dirty read, and then we have phantom read. Phantom read is that you read more than one line. So you read, let's say, whole table, or use some search. Let's give me items from 1 to 10. And then while you are doing that twice, somebody changes database and removes one of the rows or adds a row that matches your description. So this might be an isolation problem for you, or might be that it's just fine. So all these might in some case be fine for you, or it might be that you want to stop all these. So that's why we have isolation levels. There's some variance in different languages. This is from Java SQL connection, so Java-based transactions work this way. There's, by the way, excellent link here on Wikipedia. I'm not going to open it now, but if you got curious at all and all this is not familiar for you already, please go here, expend 15 minutes or half an hour and study, research, and it will be very interesting for you. But if we say transaction read uncommitted, it means that anything goes. So threads are able to access intermediate data. We can see data that's not final yet, and it might be committed or rolled back, but we can already see it. No locking going on. Very fast, very kind of weird world. Then we have transaction read committed, so only committed data can be read and seen. There's isolation and protection, typically using locks. Details vary by the database, so different database engines treat this differently. Then we have repeatable read, and now only problem that might happen is phantom read. And then we have transaction serializable, so then we have transaction support that's going to stop all the problems. And at this point you are wondering, possibly, why don't we slap that everywhere? Wouldn't that take away all the problems? And I would say go for it if you're only having single user system who is never going to do any multi-threaded. So user is never going to open two browsers, and there's only one user ever in the system. If another one logs in, first one gets kicked out. So then go for it. Because to do transaction serializable and stop phantom reads, you would need to do heavy locking. And heavy locking has a lot of penalties. So it's not going to be great life for you, probably. But it's a possible level. It's good to understand that we have these. The default level is typically transaction read committed, and it's a very good level. Just be aware what you get and what you don't get. What are the defaults? Yeah. By the way, not going to dive deeper here right now, but research for you. What happens when you have nested function calls? So you have one function calling another one, and they have all transactional annotation. What's going to happen? Is there going to be new transactions within transactions? What happens if the nested transaction gets rolled back? So just raising your curiosity here. Study on those, but I'm trying to keep this short. Deadlocks are one symptom that might happen. So you have two threads. Both are locking a resource, and both are waiting for the other one's resource to be unlocked. And then they are waiting eternally or until a timeout happens, but nobody is progressing. So deadlocks are very, very nasty, and again, understand the deadlock, keep the transaction short as possible. Don't try to do all things in transactions. Don't try to do lengthy functions that are locking, because then you will be getting a lot of trouble. So deadlocks are a relatively nasty thing that is, it's difficult to give guidance on how to always avoid them, but I have some guidance on the testing a little bit later coming up. Actually here. So testing transactions is great. I mentioned the transactional annotation, which is a Java or Spring Boot or EJB related thing. So when you slap that annotation, what happens? The scary case might be that nothing. Because depending on your configuration, annotation is just hint for something to process things, but it might be that hint is never run. So then we have a problem. It's working as a placebo. You think you have transactions, but you really don't. So that's a problem. If you want to be sure, one way to do is to just try it. So you test it. You create function, you throw an exception and see that it gets rolled back, and you are not left with any intermediate state. And I think if you are not 100% sure you are having functioning transactions, you should probably do this, because it's easy to fail, especially with the annotations. You can also see the isolation issues. That's a little bit trickier, but you start your transaction, you insert stuff, you do a lengthy delay, and in another thread or window you check to see if you can see dirty data, or you can see a new row or something like that. Then we have excellent debug logging to see how automagic transactions work, and then finally, instead of automagic annotation based, you do explicit transactions. However, that might still fail, of course. It might be that even that's not working unless you test it. And also it might be a lot of boilerplate code. So hopefully you will find a good middle ground that gives you good, easy transactions, but with as little repetition as possible. Again, topic that I'm not going to dive in deep, but please do dive in deep. So what's a two-phase transaction? When we have more than one database and you want to do atomic isolated operations over them, you have a microservices composition, and each service is having their own database, or you have database and message queue. So we have some of the principles underlined here will still apply. There's typically a coordinator of some kind involved, and it's going to be hellish. So if you're not easily intimidated, then do your homework and understand this very well. You will get complicated and slow engines, but it's still doable. A big reason for enterprise Java beans was actually this world. So they were supposed to make this quite easy. But nowadays you don't necessarily need this, as long as you also understand that normal transactions work against one resource at a time. So if you want more, you need to have some coordination on top of that. Takeaways. Defaults are your friend, but defaults work as you stick to common usage patterns. So if you are doing something that's not like a sub-second fast REST request, if you are doing instead something that's being run as service for a long time, something very slow like batch operations, then you have to be a bit mindful about, especially you have to be knowledgeable about how the isolation and transactions work. So if you break the patterns, defaults might not be your friends anymore. Understand the ACID principles, all of them, not just the atomic, but also the isolation, and keep them in mind. Be aware if you want to take that a bit deeper, understand how ACID is working in your particular database. Annotations can be dangerous, so if you are using them, try to validate that they actually are doing something. With Java transactional model, it's important to understand what causes automatic rollback, what doesn't, so that you are actually rolling back if there is a problem. Everybody in the team needs to understand this so that they are not returning a value to signify an error. I've sometimes seen people return empty set or empty collection to signify that method failed. And then they are thinking that we have transactions and rollbacks. And sometimes you might, that's a kind of a, you might have a function return something and not throw an exception to not fail the transaction, and then that's okay. But understand how it's working. Everybody in the teams has to be clear on this. Peer reviews do magic here. So if there's even one guy who understands this, then you probably, if you peer review things together or pair program, then you will spread the good knowledge and understanding. You will not see ever these transaction isolation problems on single-threaded testing. So if you test on laptop or running single-threaded integration tests, everything looks fine. So if you want to really see good multi-threaded performance tests, well, use things like JMeter or Gatling. I love both tools because once I got a steaming pile of some legacy code from another company that we were supposed to take and embrace and continue developing and running. And I had some suspicions on the transaction model when I was going through these. And then I did a Gatling test. It took about 1 hour. And I put some realistic, like multi-users trying to do same things. And then I multiplied the user count to 100. Put 100 users at the same time to same part of the application. Well, turns out that the application was fine when one user was using it. It immediately failed when two were using. So we started to see data corruption and deadlocks and all kinds of funny stuff. So their transaction handling model had been pretty much copy this bit from Stack Overflow and then slap that transactional annotation before every class everywhere in the code base, and then never test anything. So just assume that everything works. It's going to read your mind and work perfectly. So it wasn't working perfectly. We kind of had to explode everything and build it again from scratch until it started really working. So that was horrible. And fortunately, I've never seen that done in my own company. Yet I try to do little info sessions like this to just make sure that the base level of knowledge is there. So then there's other levels. You can dive very deep here. Every database logs things differently. They do the durability differently. And if you think that this was fun, this is a relational database transaction model. Well, today we deal a lot with NoSQL databases and cloud databases, document databases. So there's a whole lot of more. There's some stuff with no transactions, and then you have to understand concept of document and how to model things that they work as atomic unit there. There might be NoSQL database with transactions like MongoDB, for example, or DynamoDB. And then there's always some kind of nuances and limitations to be aware of. But I would say how you take this to next level. You take the database that you are working with, at least for multiple months, and then you dive in deep there and you read more and you interpret the generic concepts here, atomicity, isolation, how the transaction is working, how is the loggings working, or is there any transactions, and then you apply it and you dig deeper, and then you get really good at this thing. So I started this little lecture by saying that sometimes I get really bad answers for these questions, but on the other hand, sometimes I get really, really good ones, and that those answers make my day. Most of those people end up working with us, so it might pay to dig a little bit deeper. If you are full stack, I think the stack starts from the back end of the back end, so whatever you have the resource there, at least a big part of the team should be very good at that area as well, not just Java. Java 14 is much fun and records are important, but it doesn't really matter if you're using them if your database is all screwed up. So this layer, if you learned anything new now, I would say summer is great time to take some time for yourself and dig deeper, go deeper, do some research, do a video of your own, or do a blog article on this. You will learn more. And I actually have some demos coming up as well, but I don't like to make these very long. So I think this theory part is here, and I'll do the demos another time, perhaps another video. So thank you for watching. Hopefully this was educating and entertaining. And I would like to say that if you like these videos, if you like to see more, please get the feedback loop going. So if you're saying that you like these, if I get that feedback, that makes me want to do more. If you're thinking this is trivial, useless, then easiest thing in the world is to leave some bad feedback or say that don't leave any feedback. And that tells me that it's not worth doing these. So feedback lets us grow, and if I made any mistakes here, leave feedback on that, because that helps me grow. It's always very exciting to put something of your own making, some claims and some kind of stuff out there in the internet for people to see. Well, I would say that hopefully I didn't make much mistakes, but I love the mistakes as long as they are caught. So get that feedback loop. For me, tell if I made any mistakes, if this is good stuff, if you want more, and then we'll make more. There will actually be anyways some more coming, but if you leave some good feedback, there might be even more coming up. Okay, thank you. Have fun.